So drawing pictures is a key aspect of working with either data sets or equations. In section 1.2, we're going to take a look at using a picture to answer a question that we might not be able to answer easily without drawing the picture. So here's our question. Let f of x equal e to the negative x minus 1 divided by x. And create a graph that explores the limit as x approaches 0 of f of x. Notice that if you put 0 in the numerator, you have 1 minus 1, which is 0, and in the denominator you have 0. So just plugging in the value of a gives you an indeterminate form 0 over 0. So there is not necessarily a very simple way to see what the limit is. However, if we draw this function and we plot the curve over an interval containing 0, we may be able to see very easily what's happening. So we begin by loading a package. Remember, the pound sign creates a comment in the IDE, and anything to the right side of the pound sign while you're in a code chunk is not computed by the IDE. It's just documenting what you're doing or it's explaining what it is that you're doing. The library function allows you to load packages. Packages are one of the fundamental units of collections of codes and data sets. So the tidyverse package is one of the packages that is frequently used to do lots of common tasks. Note that you'll have to install the packages before you can load them. So we define f as a function of the variable x, and if we want e to the minus x, we use exp of minus x. Then we have minus 1 and we divide by x. Notice that up here there are no parentheses around the numerator because it's clear what the numerator is. However, when we're defining the function inside the IDE, we have to use parentheses to surround the numerator. That way it's all grouped together. If we didn't do that, we would not be defining the same function. Then we can define the value x0, which is a in the notes. Then we can create a tibble. M is assigned to be a tibble with two columns, x and y. After that, we can plot the tibble. So G is assigned to be ggplot connected to the data M that we had just defined. And then we add a geom line with mapping equals AES. The x aesthetic will be the x column of the data argument. The y aesthetic will be the y column of the data argument. The color of the line will be maroon, and the size will be 1.2. That's geom line. What geom line does is it connects the dots in the order of the x aesthetic. So it's going to go from left to right connecting the dots. And that's how we can get a picture of the calculus function. Geom v line, that's for vertical line. If I want to add a vertical reference line to a plot, we use geom v line and we specify the x-intercept. So if a line is going up and down, it's going to hit the x-axis. And this can be a dashed line that is dark orange and of size 1.2. So that's the width of the line. Then we can use the labs function to specify the labels for the x-axis, y-axis, the title, etc. And lastly, we can use the theme function to specify non-data aspects of our plot. And then we can display the plot by printing out G, which we had defined. Now, in practice, as you go forward in your career and in your education, you would learn to use code snippets. And with the code snippets, you don't have to remember all the details of every function. You just type in the beginning of the function, then a little box will open up and you can choose a snippet and it will insert that collection of code associated to the snippet. So on the videos for the assignments and the quizzes and the tests, you will see me going through that. That way you don't have to remember all of these details. Your brain can kind of focus on the bigger pictures and the main steps. And finally, when we get the graph, it's kind of clear what's going on from the picture. Here is the value of a, 0, and this is a curve of that function. And as we get close to this orange dashed line, it looks like the limiting value is a -1. Okay. So being able to plot functions allows you as a scientist to see what's going on. And for most of us, we couldn't see what's happening without drawing a picture, without using something like this to connect the dots and get a nice picture. Okay, that is it for the section 1.2 video. My advice is to make drawing pictures part of your skill set. Okay, if you go into calculus or statistics, there are many plots that you would like to be able to make. You would like to be able to make them accurately and quickly and be able to customize them. And this is one of the tools that can help you do that. Okay, I'll see you on the next video. Goodbye.